welcome to cryptography session. Today I am going to give an example and explanation for a multiple encryption scheme. It is implemented with the help of DES algorithm. So this will be explained only with the DES algorithm. So multiple encryption means more than one time we should implement the encryption mechanism in DES algorithm. So basically, two types of encryption notation is available. Multiple encryption means, so totally two types are available. The first type is double DES. Double DES means two times we are implementing the encryption mechanism. And then the next scheme is triple DES. Three times we are using it. So double means for a single encryption we should use only one key. For double encryption means we should use two keys. In triple DES, there are two possibilities are there. Either we may implement the triple encryption scheme with only two keys, or we may able to implement that triple encryption with the help of three keys. So I will give an explanation for the difference between double DES and triple DES in forthcoming session. Double DES means we implement the DES encryption two times on plain text. So totally two keys are used. For the first key is K1. This is implemented for encryption of plain text. So if we take encryption of P, so this will be taken as X. So the resultant X value is once again encrypted with the help of K2. Then we may able to retrieve the ciphertext notation. So in the reverse side, if you want to decrypt that notation, we should implement a decryption. So outer part, the last encryption is done with the help of K2. So we should use K2 for the resultant value. So this resultant value is named as X. So first I want to decrypt that X value with the help of K2 key. Then once again I decrypt this value of X. Then we may able to retrieve the plain text value. So this is the ciphertext value. So this is ciphertext. So the ciphertext is decrypted with the help of K2. Then we get X value. That X value is once again decrypted with K1. Then we may able to get plain text P. So this is retrieved here. So encryption of K1 of P is X. Decryption of K2 of C is also X. So attack is also possible for encrypting P and decrypting C, these key values. So the attacker is in need to find out this K1 and K2 with the help of plain text and ciphertext values. So this is the diagrammatic representation of implementing double DES. So for a single DES notation, we should use a 56-bit key. So if you are implementing double DES, two keys are used. So 56 into 2, totally 112 bits of keys are used for double encryption side. So the attack which is done at double encryption scheme is called meet in the middle attack. So how can it will be done means, we may able to encrypt the plain text P with all possible combination of K1 value. So this is the first plain text, first key K1. So the size of K1 is 56 bit. So I want to retrieve 2 power 56 possible key values for encrypting plain text. So the answers are stored in the table and we sort out those answers. So here X is nothing but encryption of K1 of P. So these values are sorted out. Then in another table, we do the decryption procedure. For the ciphertext value, at that purpose we are using K2 notation. So another side, we implement a decryption. Decryption is done at ciphertext with the help of K2. That is also implemented with 2 power 56 possible values. This is also sorted out. So for implementing these type of attack, the attacker should know the corresponding plaintext and ciphertext values. Using the known plaintext and known ciphertext value, the attacker is trying to find out the K1 and K2 value. So that is the main motive of meet in the middle attack. So this is a given value. We encrypt P with the help of K1 and we arrange the encrypted value. The answer of encrypted value is named as X. So those values are sorted out. And at another side, we are implementing decrypting the ciphertext value with the help of all 2 power 56 possible K2. At any situation, at least one value of X at left side table is matched with the right side table. If matching is done, we may able to retrieve its corresponding K1 and K2 value from the table. So this type of attack is called meet in the middle attack. And the second type of multiple encryption is called triple DES. So this triple DES technique may implemented with two ways. One is a 2-key representation, another one is 3-key representation. Here it is a 2-key representation. If you are using 2-key, first we should implement encryption, then decryption, and once again encryption. So this is the way we are doing it. So for encryption purpose, we are using K1 value. For decryption, we are using K2 value. So here only 2 keys are used. This encryption is done with K1, decryption is done with K2. So encrypt K1 plaintext value with the help of K1. So this is the X value. This X value is decrypted with K2, that is called as Y. Once again, that Y value is encrypted with K1. So this is the triple DS notation with 2 keys. If the same problem is implemented with 3 key means 3 different keys are used. So K1, K2, K3. So encryption is done with the help of K1 and K3 value. Decryption is done by K2 value. So this triple DES scheme is implemented in an internet application which are all mainly PGP, that means pretty good privacy, and SMAIL, secure multiple internet mail extension technique. So in these two applications, this triple DES with 3 keys are used. So this is the meet in the middle attack technique which are all implemented under a triple DES scheme with 3 keys. So this is the resultant value. So encryption of K1 of P answer is taken as A. Once again, we decrypt this value. So this is not encryption. So we decrypt that value with the help of K2. So the answer is B. The answer B is once again encrypted with K3. So the answer will be taken as C. So this is the generalized notation of triple DES. So attack is also possible with the help of knowing A and C value. Ciphertext, if the ciphertext value and A values are known, they can able to draw the diagrammatic representation, tabular column with all possible combinations of 56 values. If any matching will be done, they may able to retrieve the corresponding keys, K1 and K2 value. Because for encryption, at both end only K1 is available. So if you know A and C value with the same type of K1 value, we may able to retrieve the table rights notation. So in this way, they try to get a K1 and K2 value. This is also come under a meet in the middle attack technique. So the next block cipher mode of operation technique will be discussed in next session. Thank you.